of examples on how to do a hypothesis test when the population standard deviation is known. If you look at the Let's Do It 10.2, it's a known standard deviation population of 2. This occurs very rarely, only in theory. So we'll use some theoretical type questions, and then we'll move to some that would actually occur in the real world. If you notice, we're talking about mice through a maze. There is my null and my alternative hypothesis. And if we look at our sample size, we have a sample size of 10. And if you read further in the question, this follows a normal distribution. Since the population is normally distributed, from Chapter 8, we will assume that the sample means are normally distributed as well. In the center here is 18. And I'm wondering if this noise is going to decrease their time and make them faster. So what I'm looking at is, are these going to be on the left, slower, less than 18? So here's a look at my picture of what that's going to look like. And I should actually have my tails come closer to that axis. Here would be 18. And it looks like when I went and did 10 mice and ran them through this, they have an average together of 17. 17 is lower, so we might as well go ahead and test. Is 17 seconds from 10 mice on average different enough to say this noise stimulus is making them go through the maze faster? Because we're looking at a sample mean and not a single observation, notice my standard deviation is the standard error, which was sigma over the square root of n. Plugging this into your calculator, I would always use my numerator first, which is -1. Tells me I'm below the center. And then go ahead and plug 2 divided by the square root of 10. This is done for you. Check on your calculator that you do, in fact, get -1.8. So what I'm looking at here, if you remember, we're standardizing. So this really becomes a 0, and this 17 really becomes -1.58 steps below the mean. Looking in our table on page 407, if you look this number up, you get -0.0571. So as a percentage, excuse me, it's positive because area is positive. It is below, but the area is positive. And because I'm looking at this area to the left, I get to take that value, and it's 6%. So what does that really mean? The probability that if I ran 17 mice through this maze, I have a 6% chance that they would have completed the maze in 17 seconds or less. So comparing it to the 10% level, this 6% as a probability is unlikely, only 6% of the time. Is it unlikely enough to go through all this hassle and make a change? Well, the researcher said at the 10% level is when I'm going to make a change. I'm already down at the 6% level, so I'm going to make a change. Now, when you write your decision, you need to make sure that you state the level of significance. So at the 10% level, we are going to reject the null. So what does that really mean? It means that there is enough evidence. Evidence is my data. My data is significant enough to suggest, we're not proving, we're just suggesting that the average time to complete the maze is less than 18 seconds. Okay, let's try another one. Here's another situation. A researcher is talking about wind speed. So spend a moment. You may want to pause the video to read this question. But basically, we have a sample of 32. That's very important because it does not say in here that it's a normal distribution on the population. So because we're going to be looking at a large enough sample, we can use the central limit theorem and assume that my sample means are going to be normally distributed. It currently had an average of 8.2 out of that sample, and my original average was 8. Is 8 and 8.2 different? Yes, they are, but are they different enough? Well, my null is that my average should be 8. My alternative, let's see, am I looking for less than, greater than, or just changing, thinking that it's changed? And all the researcher is saying is that this wind speed is not 8, not equal to 8. So it's just saying that the wind speed has changed. I'm looking at the size of my sample, or if the population is normally distributed, that allows me to continue. Because I'm looking at samples, I'm going to go ahead and put 8.2, the new average, minus the old, over the standard deviation of the population, divided by the square root of the sample size, which is 32. Plugging this in your calculator, you get 1.89. Notice 8.2 is above 8. In fact, it's almost 2 steps above. So let's go ahead and get a picture of what is happening here. Here's my center 8, which I standardize it as 0. And I'm looking, my value out for my sample means is 1.89, quite a bit above. But because I'm not sure if it's going to be above or below, it could have also been down here. And that's what happens with a two-sided test. I actually don't have just one area, I have 2 areas. So looking at my rejection region, this one is two-sided. The one above, the rejection region, was to the left, less than. This is two-sided. So finding my p-value, if I go to my book and look up 1.89, what do I need to do with that 1.89? I need to subtract it from 1. So I take the value in the table and subtract from 1, and you get this to be 0.0294. This little space is about, we'll just round that, which we really shouldn't, but right now we're not so much worried about decimals. It looks like about 2.9%, so it's going to be 3%. Why would I write 6% there? Well, I'm thinking ahead. If this space is 3%, this space is 3%. So what you really could have done when you looked in your table, because it's a curve that is symmetric, and this was a problem out of your web work, you could have looked up negative 0.89 and looked for area to the left and then doubled it because of that two-sidedness. So my p-value, which is about 3%, I need to multiply that by 2. So I get 6%. Again, like the problem before, 6% is unlikely. Is it unlikely enough? Well, we need to go up here and look, what level did they set the change to be at? The alpha level, 10%. So at the 10% level, what are we going to do? Well, 6% is unlikely. At the 10% level, it's actually very unlikely. So I can reject the null. So what is that saying? There is enough evidence to suggest. What are we suggesting? That the average wind speed is not greater, is not less than, but is different or not 8 miles per hour. Notice when you do a two-sided test, you have to double that area, which makes your chance of rejecting it that much less because you had to double that area. Had the researcher known that he predicted the wind, or he or she predicted the wind speed to be greater, then we would have only had to take this area and not double it, therefore giving me a better chance of rejecting. So a two-sided test isn't really used a lot. We want to have some sort of idea. Is it greater than or is it less than? So that concludes the lecture on knowing the standard deviation of the population.